Okay, so we are going for LR parsing technique. We're going for LR parsing technique. Uh, so LR parsing, there are quick key pointers here for you. Key pointers, quick key pointers. What are they? This is a bottom-up parser, bottom-up parsing technique. LR parsing is a bottom-up parsing, so which means that this is rightmost derivation in reverse. Rightmost derivation in reverse. Okay. If you look at shift general architecture of shift reduce parser, where the accept state is being considered as start symbol followed by dollar is the accept state in case of general shift reduce parser, right? So the upper accept case is when we have a start symbol at the top of the stack and which is followed by dollar. If we encountered such a situation, then we announce, means parser announce successful completion of parsing. Okay, because top of the stack is the start symbol and followed by dollar. So but in case of, but it is not a complete parsing technique. The top of the stack, which is nothing but the start symbol, has to be reduced, right? So in order to have a complete parsing, so in case of LR parsing, what we did is we need to do first augmentation of grammar. Augmentation of grammar. So what we need to do is augmentation of grammar. Now, what exactly augmentation of grammar means? Augmentation of grammar means if you have certain set of productions, say for example, if you have a certain set of productions, uh, uh, say S implies CC, C implies small c, capital C, or D. If this is the grammar, then in case of a general shift reduce parser, we say that $S means start of the symbol is followed by the dollar. If this is the case, condition occurs, we will say this is an accept state condition. Okay, this is in case of general general shift reduce parser. Okay, so uh, uh, in order to reduce even this start symbol, we want this start symbol to come into the right hand side of the production. So we adopt augmentation, so that we can produce everything from the start symbol. So which means the augmented form of the grammar will be S dash implies S, S implies CC, C implies small c, capital C, and D. Okay, so this is the initial form of the grammar, and this is the modified form of the grammar. So this grammar is being modified like this. So this is MODIFIE. This is modified grammar. So this is called as augmented form of the grammar. So that we want this start symbol of the grammar is to be reduced completely. So we are expecting everything from the start symbol. So the augmentation we are going to perform. So I hope you have gotten concept of why to go for augmented form of the grammar. So augmentation is being done only for one reason, that we want to reduce even the start symbol. In case of general shift reduce parsers, start symbol is on the top of the stack and which is followed by the dollar will announce accept state. But even then, to reduce this start symbol, further, we go with augmentation form of the grammar. So this is what is there. Okay, and the second important important point with LR parsing is uh, we dot we use dot operator. Okay, we use of dot operator. So this is uh, dot operator. Okay, so here this is important. So use of dot operator. Now, what exactly use of dot operator means? Uh, use of dot operator means, see, if you have a grammar, say x implies a, b, and c. If you have a grammar, say x implies a, b, c. Say a implies a, b implies b, and c implies, say, for example, c. Then when we go for using a dot operator, the augmented form of dot operator is, augmented form of this grammar is, say, x dash implies x, x implies a, b, and c, a implies a, sorry, a implies a, b implies b, and c implies c. This is nothing but augmentation. Okay, this is the augmented form of the grammar. Now, after augmentation, what we are going to apply? A dot. Okay, so applying a dot is operator is particularly for what? Computing closures. Computing closures. What we are doing, this is computing exactly for closure. So dot operator is for closure. So which means that if you say that x dash implies dot x, so dot x, so here you need to understand dot is prior to x. So what is the meaning of this? When a dot is prior to x, which means that we are expecting some of the input from x. So we are expecting some of the input from x. What it means? It means that once we are expecting some of the inputs from x, which means that the productions that are from x has to be included. So means what? X implies dot a, b, c. Okay, so dot abc. So now see, we are expecting some of the inputs from x, so we added the x production with the dot before, so dot abc. So here dot is applied to a, which means that we are expecting some of the inputs from a, which means we need to go for this. So we have added all the production. So this is how this works. So we expecting some of the inputs from this. Now what if this dot is being shifted from this position to here in between a and bc? So means you may come across with the production called x implies a dot b c. So what this signifies here, now we generated inputs from a and expecting some inputs from B. So which means that when you have come across with this kind of production, so it means that you need, dot is before B, so you need to add B's production here, dot B. So it may be a case that you may have got again a different kind of production, a, b dot c. So which means that you have generated inputs from a and b, and you are expecting some inputs from c. So which means that you need to go for dot c. Okay, so here right, so you added a production from this also. So c is dot d. Okay, or it is in this way, so you can go for you can go in this particular way. Okay, so then in next case you may expect that it may be x implies a, b, c. So a, b, c, and dot. So what this signifies that we generated all inputs from A, B, and C. So certainly we go for reduce action here, right? So we go for reduce action further. So means what, we have generated all the inputs from A, B, and C. Okay, so this is going to be, so dot operator is playing an important role. So whenever you're going for LR parsing, please try to understand that there are some key pointers which you will need to understand. Key pointers are, it is bottom up parsing, it is rightmost derivation in reverse. In order to perform LR parsing, we need to go with the augmentation of the grammar, and we have to go for a dot operator. So augmentation form of grammar is S implies CC, C implies small c capital C or D. If this is the form of the grammar, then we need to modify that form of the grammar so that the start symbol, which is S, has to be into the right hand side of the production. So, and then the new modified grammar will be S dash implies S, S implies CC, C implies small c capital C or D. So it is in this particular case, this is the modified grammar, this is called as augmented grammar. Why it is required? Because we wanted to even reduce the start symbol of the grammar. Okay, so if we do this, then the start symbol is again further reduced. So this is the case. And use of a dot operator. So dot operator is specifically used for computing closures. So dot operators, so for applying a dot operator, you have a modified augmented grammar with you. So when you say x dash implies dot x, what it means? It means we are expecting some of the inputs from x. So which means that whatever the production that are lying with x or being defined with x has to be included. So once we are expecting some of the input from x, which means x implies dot abc. So dot abc means dot abc, x implies abc is the production. So we are putting a dot prior to this because we are expecting from x. So it is like this. So x implies abc. So A implies, now we are expecting some of the input from A, which means A's production has to be included. So it may be a case that once you add this, then the dot gets shifted. It is in between A and B. So the production will be X implies A dot BC. So which means that you are expecting some of the inputs from B. So you add a B's production with the dot preceding to this. So B dot B implies dot B. So it may be a case that once you do this, dot gets shifted in between B and C. So the production becomes x implies ab dot c, which means that you produce some of the inputs from A and B and expecting some inputs from C. So you added the C's production. So at the end, what you can do is you can see is that dot gets shifted after C, which means that you have produced all the words from A, B, and C, and then now you can call for a reduce action. Okay, so this is really very important. So this is the augmentation form of the grammar and the use of dot operator.